According to Underwriters Laboratories Standard 50/50E, hermetically sealed means so sealed that gases cannot enter or escape when operating within the specified pressure and temperature ranges. This typically requires the use of a welded or gasketed closure that prevents the ingress of gases. For Class 1 Division 2 Group C and D hazardous locations, National Electrical Manufacturers Association Type 4X enclosures are considered dust ignition proof and weatherproof, but they are not hermetically sealed. If a level switch has a non-sealed relay switch, even if it is installed in a National Electrical Manufacturers Association Type 4X enclosure with an O-ring on the lid and cord grip, it cannot be considered hermetically sealed because the relay switch is not gas-tight. If a level switch has an explosion-proof enclosure, an actual seal-off is required for the cable in addition to the O-ring on the lid and cord grip. This is because the explosion-proof enclosure is designed to prevent the ingress of gases through the cable entry. Acceptable methods for sealing the cable entry for an explosion-proof enclosure include firstly, conduit seal-offs, secondly, listed quick connect fittings with O-rings, and thirdly, listed cord grips with O-rings. A hermetically sealed device is one that is completely sealed against the entry or escape of gases. This is critical in hazardous locations where flammable gases or vapors may be present. The enclosure must prevent these substances from entering and potentially causing an explosion. National Electrical Manufacturers Association Type 4X enclosures provide a degree of protection against corrosion, water, and dust, but they are not designed to be gas-tight. The O-ring on the lid and the cord grip provides some sealing, but they are not sufficient to create a hermetically sealed environment, especially if the relay switch inside the enclosure is not itself sealed. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the outside environment. However, to maintain this integrity, the cable entry point must also be sealed to prevent gases from entering through the cable. A seal-off is a fitting that is installed in the conduit or cable run to create a barrier against the passage of gases, vapors, or flames. It typically involves packing the fitting with a sealing compound that hardens and forms a gas-tight seal. Quick connect fittings with O-rings can provide a convenient way to connect and disconnect cables while maintaining a seal. However, it is essential to ensure that the fittings are specifically listed for use in hazardous locations and that the O-rings are compatible with the gases or vapors that may be present. Listed cord grips with O-rings can also provide a means of sealing the cable entry point. Again, it is crucial to ensure that the cord grips are listed for use in hazardous locations and that the O-rings are compatible with the environment. When selecting sealing methods, always refer to the applicable codes and standards, such as the National Electrical Code, and consult with a qualified electrical engineer or inspector. They can help you determine the appropriate sealing methods for the specific application and ensure that the installation meets all safety requirements. Failing to properly seal the cable entry point can compromise the integrity of the enclosure and create a significant safety hazard. In Class 1 Division 2 locations, the risk of explosion is reduced compared to Division 1, but it is still present. Therefore, it is essential to take all necessary precautions to prevent the ingress of flammable gases or vapors. The National Electrical Code provides detailed guidance on the requirements for electrical equipment in hazardous locations. It specifies the types of enclosures, wiring methods, and sealing techniques that are required to ensure safety. When working in hazardous locations, it is essential to be familiar with the National Electrical Code and to follow its requirements carefully. It is also important to use only equipment that is specifically listed or approved for use in hazardous locations. This equipment has been tested and certified to meet the stringent safety requirements of these environments. In summary, to create a hermetically sealed system in a Class 1 Division 2 Group C and D hazardous location, firstly, ensure the level switch itself is sealed. Secondly, house the switch in a National Electrical Manufacturers Association Type 4X enclosure isn't sufficient on its own. Thirdly, an explosion-proof enclosure requires a seal-off for cable entry. And fourthly, use listed quick connect fittings or cord grips with O-rings if they meet hazardous location standards. Always refer to the National Electrical Code and consult with qualified professionals to ensure compliance and safety. National Fire Protection Association 70, the National Electrical Code, defines hazardous locations based on the properties of the flammable materials that may be present and the likelihood of those materials being present in ignitable concentrations. Class 1 locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those in which the hazardous material is present under normal operating conditions, frequently present because of repair or maintenance operations or because of leakage or equipment failure, or in which equipment breakdown or faulty operation could release hazardous material and also cause simultaneous failure of electrical equipment. Division 2 locations are those in which the hazardous material is handled, processed, or used, but is normally confined within closed containers or closed systems from which it can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or in which hazardous material is normally prevented from being present in ignitable concentrations through positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or that is adjacent to a Class 1 Division 1 location, and to which hazardous concentrations of gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air and effective safeguards against ventilation failure are provided. Group C includes atmospheres containing ethyl ether, ethylene, or cyclopropane. Group D includes atmospheres containing acetone, ammonia, benzene, butane, ethanol, gasoline, hexane, lacquer solvent vapors, methane, natural gas, naphtha, propane, or other similar flammable gases or vapors. Hermetically sealed equipment is designed to prevent the ingress of flammable gases or vapors into the enclosure, even under abnormal conditions. This is typically achieved through the use of welded or gasketed seals that are designed to withstand high pressures and temperatures. The goal is to ensure that any electrical components within the enclosure cannot ignite the surrounding atmosphere. National Electrical Manufacturers Association Type 4X enclosures are designed to provide protection against corrosion, water, and dust. They are commonly used in industrial environments where equipment is exposed to harsh conditions. However, National Electrical Manufacturers Association Type 4X enclosures are not necessarily hermetically sealed. The O-ring on the lid and the cord grip provide some degree of sealing, but they are not sufficient to prevent the ingress of gases or vapors under all conditions. If the level switch contains a non-sealed relay switch, the switch itself may be a source of ignition. If flammable gases or vapors enter the enclosure, they could be ignited by the relay switch, leading to an explosion. Therefore, it is essential to ensure that the level switch is either hermetically sealed or installed in an enclosure that is designed to contain an explosion. Explosion-proof enclosures are designed to contain an internal explosion and prevent it from propagating to the outside environment. These enclosures are typically made of heavy cast metal and have tightly fitting covers. However, even with an explosion-proof enclosure, it is still necessary to seal the cable entry point to prevent gases or vapors from entering the enclosure through the cable. A seal-off is a fitting that is installed in the conduit or cable run to create a barrier against the passage of gases, vapors, or flames. Seal-offs are typically required within 18 inches of an enclosure that contains arcing, sparking, or high-temperature components. They are also required where conduit enters an enclosure from an area with a different hazardous classification. Seal-offs are typically packed with a sealing compound that hardens and forms a gas-tight seal. The sealing compound must be compatible with the gases or vapors that may be present. Listed quick connect fittings with O-rings can provide a convenient way to connect and disconnect cables while maintaining a seal. However, it is essential to ensure that the fittings are specifically listed for use in hazardous locations and that the O-rings are compatible with the gases or vapors that may be present. Listed cord grips with O-rings can also provide a means of sealing the cable entry point. Again, it is crucial to ensure that the cord grips are listed for use in hazardous locations and that the O-rings are compatible with the environment. When selecting sealing methods, always refer to the applicable codes and standards such as the National Electrical Code, and consult with the qualified electrical engineer or inspector. They can help you determine the appropriate sealing methods for this specific application and ensure that the installation meets all safety requirements. Failing to properly seal the cable entry point can compromise the integrity of the enclosure and create a significant safety hazard. In Class 1 Division 2 locations, the risk of explosion is reduced compared to Division 1, but it is still present. Therefore, it is essential to take all necessary precautions to prevent the ingress of flammable gases or vapors. Always consult the National Electrical Code for specific requirements related to wiring and equipment in hazardous locations. For Class 1 Division 2 locations, Section 501.10 subsection B of the National Electrical Code details the approved wiring methods. Some highlights include that threaded rigid metal conduit, threaded steel intermediate metal conduit, or a tight mineral insulated metal sheet cable is required. In Class 1 locations, raceways shall be threaded and shall be made wrench tight. Where rigid non-metallic conduit is used, it shall be installed in accordance with the provisions of Article 355. Boxes, fittings, and joints shall be provided with threaded enters unless identified for the purpose. Class 1 Division 2 requires explosion-proof equipment or intrinsically safe systems. Explosion-proof equipment must be able to withstand an internal explosion of a specified gas or vapor and prevent the ignition of the surrounding atmosphere. Intrinsically safe systems are designed to limit the amount of energy available to the point where it is insufficient to ignite a flammable gas or vapor. It's important to note that even if the equipment is rated as explosion-proof, it must be installed correctly to maintain its integrity. This includes ensuring that all joints and connections are properly tightened and that any seals are in good condition. When selecting equipment for Class 1 Division 2 locations, it's crucial to consider the specific gas or vapor that may be present. Different gases and vapors have different ignition temperatures and explosion pressures, so it's essential to choose equipment that is rated for the specific hazard. In addition to explosion-proof and intrinsically safe equipment, other methods can be used to reduce the risk of explosion in Class 1 Division 2 locations. These include ventilation, which can dilute the concentration of flammable gases or vapors, and inerting, which involves replacing the air with an inert gas such as nitrogen. It is recommended to consult with a qualified electrical engineer or inspector to determine the best approach for your specific application. They can help you assess the risks and select the appropriate equipment and methods to ensure safety. Remember that working in hazardous locations requires specialized knowledge and training. It's essential to follow all applicable codes and standards and to take all necessary precautions to prevent explosions and other hazards. Always prioritize safety and never take shortcuts that could put yourself or others at risk. National Fire Protection Association 496 provides standards for purged and pressurized enclosures for electrical equipment. Purging involves removing a flammable gas or vapor from an enclosure by flushing it with a non-flammable gas. Pressurization involves maintaining a positive pressure of a non-flammable gas inside the enclosure to prevent the entry of flammable gases or vapors. These methods can be used to protect electrical equipment in hazardous locations, but they must be carefully designed and maintained to ensure their effectiveness. Other factors to consider include the temperature rating of the equipment, the presence of corrosive substances, and the potential for mechanical damage. By carefully considering all of these factors, it is possible to select and install electrical equipment that is safe and reliable in Class 1 Division 2 Group C and D hazardous locations. Remember that safety is always the top priority.